A journey through the Artemis II project, Orion's Voyage. How many of us have heard about the alleged hoax moon landing? Many, I assume? Additionally, we all had a subliminal belief that the hypothesis might be true. But now that NASA is launching the Artemis missions, the first crewed mission to the moon since Apollo in 1972, there is no room for conspiracy theories any longer. Additionally, you will participate in every phase of the flyby mission and serve as a witness for upcoming generations. The Orion module and the ICPS cryogenic propulsion stage were tested around the moon in Artemis I, the first stage of the three-stage mission. By 2024, the Artemis project will move on to its second phase, Artemis II, which will include multiple flights with human crews that will fly aboard the Orion spacecraft. No woman has ever had the chance to walk on the moon, but that day is almost here thanks to the American Space Agency's Artemis mission, which aims to return people back to the moon somewhere between 2024 and 2025. And the program's name, which honors the Greek goddess of hunting, nature, and chastity who was the offspring of the king of the gods, Zeus, and the Titan Leto, was given precisely because there were women on board the following lunar mission. She was also thought to be protective of women, children, and childbirth. There are further differences between Artemis' adventures and those of her twin, Apollo, the god of the sun, music, the arts, healing, prophecy, and justice. Let's explore the exciting distinctions between these two missions, which are 500 years apart in age, and see what this Artemis expedition is intended to accomplish. The astronauts will use this mission to get ready for the ones that will set up a base on the moon. The second phase of the Artemis project, Mission Artemis II, will be eagerly anticipated. 4 astronauts will travel to the moon again aboard the Orion spacecraft in 2024 as per the mission plan, which is as follows. The mission's objectives are to investigate the lunar environment, showcase cutting-edge technology, and establish a long-term presence on the moon. Do you still recall Neil Armstrong's famous phrase, "One little stride for man, one big leap for mankind"? NASA launched the Apollo expedition, the first human mission to the moon, from 1969 and 1972. The mission's objectives included sending 3 astronauts to the moon, gathering lunar surface samples, and carrying out a number of scientific investigations. The effects of gravitational fields were studied, the lunar surface's composition was investigated, and seismic observations were all part of these investigations. NASA's Artemis mission, which will attempt to launch the first crewed mission to the moon since 1972, is the Apollo mission's successor. 4 astronauts would participate in this trip, and they would circle the moon while gathering data and deploying robotic landers. The mission's objectives are to investigate the lunar environment, showcase cutting-edge technology, and establish a long-term presence on the moon. The goal of the Artemis mission was different from that of the Apollo mission. The Artemis mission is focused on establishing a prolonged presence on the moon, creating a base, and advancing human exploration to Mars and beyond, whereas the Apollo mission was concerned with investigating the lunar surface and gathering data. The crew capacity varies as well. Although an Apollo flight typically had 3 astronauts on board, the Orion spacecraft will be able to carry up to 4 people on the Artemis mission. The mission will launch using the same procedure as the Artemis I mission, with a Space Launch System, SLS, launching the Orion spacecraft with a crew of 4 in the preliminary cryogenic propulsion stage, ICPS. The SLS will detach and come back to Earth after it has entered Earth's orbit, while the ICPS will send the Orion spacecraft to the moon using hydrogen and oxygen. ICPS will be the only fuel source for Artemis II, allowing for a faster trip that keeps the crew safely outside of the Van Allen belts and their high radiation levels, in contrast to Artemis I, which depended on Earth's gravitational pull to reach the moon. Orion will be covered with a double layer of aluminum and Kevlar, the same material used for the anti-water beak echo blankets, to protect the astronauts from radiation and any hits from small space debris. 2 thin layers of defense are more effective than 1 large layer, according to NASA experts. The Orion spacecraft will be outfitted with many layers of protection to shield its occupants from any potential threats linked with passing through the Van Allen belts. An advanced EMF radiation shielding system, which is built to absorb a lot of radiation, will form the outermost layer of defense. An active magnetic shielding system will be added to this radiation protection system to further safeguard the astronauts from any lingering radiation. A layer of ceramic plating will also be installed on the spaceship, which will absorb radiation before it may harm the astronauts. The Orion spacecraft protects its astronauts from the harmful radiation of the Van Allen belts by allowing them to pass through it in little more than 2 hours. This is feasible because the spacecraft is propelled by the Moon's gravitational and inertial pull, and small direction changes may be made by turning on the engines. The crew will be able to confidently investigate the lunar surface and explore its dark side once they get at the Moon. Some radioactive particles still manage to enter the astronauts' bodies in spite of all these safeguards. The radiation doses in these situations are low, but if they are allowed to build up for a long enough period of time, they can result in cancer and other long-term health issues. The mission team makes sure that the astronauts spend as little time as possible inside the Van Allen belts in order to reduce the quantity of radiation that they are exposed to. The Apollo missions produced a wealth of information for NASA. This priceless information has been used to prepare for planned Artemis flights, allowing a trip back to the Moon. Those of us who weren't around to watch the first person set foot on the Moon will get the chance to witness a live lunar landing thanks to Artemis, who is supposedly the embodiment of Apollo's heritage. We consider the great lunar landings that came before us, paving the way for ongoing lunar exploration and inspiring the Artemis generation as we look forward to humanity's return to the lunar surface. We'll examine some of the most significant differences between NASA's Apollo and Artemis programs. Even while there are certain similarities, every software has its own distinctive qualities. 1. The different crew capacity of the Orion and Apollo command modules are a significant distinction. While the Apollo command generally held 3 astronauts, the larger Orion spacecraft has room for a 4th, making a total of 4 Artemis astronauts possible. Approximately 316 cubic feet of space were added to the spaceship to make room for the extra astronaut. In the 1960s, the US and the Soviet Union competed for space supremacy, turning the idea of reaching the Moon into more of a political than a scientific project. 6 lunar landings were placed over a 4-year period, making the Apollo missions the highlight of the era in which they were making progress. Through long-term missions, the building of lunar bases, and the development of a space portal, the Artemis missions seek to establish a more permanent presence on the Moon. By developing long-term missions, lunar colonies, and an orbital gateway, they hope to establish a steadfast and continuous presence on the Moon. The Apollo astronauts undoubtedly carried out exhaustive tests and collected priceless lunar samples, and the Artemis missions will build on that study by placing even more of a focus on scientific exploration and inquiries. In order to gain the knowledge and tools required to support longer space exploration, such as a journey to Mars and beyond, we will also prioritize building a sustainable lunar economy. Orion has 2 redundant flight computers operating simultaneously, as opposed to Apollo's single flight computer. It has a total of 4 redundant systems because each of them comprises of 2 redundant computing units. In addition, the weight of one of Orion's redundant computers is only 75% that of Apollo's single onboard computer. Additionally, an Orion computer is 20,000 times quicker and has 128,000 times more memory. The Space Launch System, in contrast to the Saturn V rocket, which had 3 floors, is propelled by a powerful central floor with 2 solid rocket boosters attached to the sides, as well as an upper floor known as the Interim Cryogenic Propulsion Stage, ICPS, which can launch the Orion spacecraft to the Moon. As the backbone of the launcher, the core stage, the largest rocket component, ever supports the weight of the payloads, the upper stage, and the Orion spacecraft. When SLS lifts off and ascends, it generates 15% greater thrust than Saturn V. 50 years apart, the Saturn V and SLS are built in the same facility. The instrument unit, which provided the navigation and attitude control system, telemetry, and environmental control on Saturn V, served as the nerve center of the rocket. Before the Orion spacecraft is attached to the top of the SLS, the Orion stage adapter is the last component of the SLS. During Artemis 1, it housed auxiliary payloads. As they travel through the Van Allen belts and investigate the dark side of the moon, astronauts will be shielded from radiation by the radiation shielding devices on board the Orion spacecraft. The mission crew is sure that the astronauts will stay safe and in good health throughout the journey by combining many layers of shielding and minimizing the amount of time spent in the radiation zone. As a result, the Orion spacecraft will serve as a standard for future space travel and an excellent illustration of how to properly cross radiation hazard zones. The two astronauts will use the Orion spacecraft to return to Earth at the end of their mission. Since this is the first lunar footprint in almost 50 years, it will be a historic occasion. As they set out on this historic adventure, let's wish them the very best and a safe journey. This video has come to an end. I appreciate you viewing. Don't forget to like and subscribe to keep up with all the fascinating astronomy news.